Hello, this video is designed to help you review how to graph quadratic equations when they are in standard form. So the first part here of graphing quadratic equations in standard form has to be identifying the different parts of the equations that give you different information. So when it's in vertex form, it's going to look like this. So it's going to be y equals a parentheses x minus h parentheses close parentheses plus k. And there's an exponent on the parentheses that I forgot to put on there. But you can see it on your equation. So here a, h, and k are 2, positive 4, and positive 4. So let's move on to the first part, which asks to identify the vertex. The h, which is the x-coordinate, is going to be the opposite of how we see it in our equation. So since you see it as positive 4, your vertex will be negative 4 for the x-coordinate, and the k does stay the same. So moving on to part B, but let's plot that point on the graph here. So it's right there where you see it on red. That point will be your vertex. And it's either going to be the highest or the lowest point, depending how your parabola opens, which is the part B that we're going to answer here. Does it open up or down? So A is that first number that you see outside the parentheses next to it. So A is positive 2. Since the parabola, A is positive 2, the parabola is going to open up because of that. So anytime A is a positive number or value, it will open up. So your parabola will look like a U, where the vertex is the lowest point. So the point that we plotted right there on the graph is the lowest point. And now we're going to use the t-table to find two other points there so that we can graph our parabola. So this screenshot comes from another problem, so I forgot to erase that equation there, but we'll fix that right now. So how do we choose the other 2 points that we're going to be using to find, to graph our parabola? So pretend that you have a number line. So we start with 4. So there's numbers to the right and to the left of 4. So negative 6, negative 5 are to the left of negative 4, and negative 3 and negative 2 are to the right. So you get to choose which one you want to use. And I already fixed it right here for the equation. So I'm going to choose the right side. The 2 numbers are to the right of negative 4, which is negative 3 and negative 2. Once you have your x coordinates here, you're going to plug it into the equation everywhere you see x, which is only one part, and that's inside the parentheses. So we'll replace x with the x coordinate that we're working with. So PEMDAS says to do the inside of the parentheses first, so we'll solve that first. Negative 3 plus 4, that gives us 1. And I'll remove the parentheses since there's only one number inside there. But I still had an exponent of 2, so I'm going to carry that on with me. Then we do exponents next. 1 square is positive 1. Now, how do we get that positive 1? Well, 1 square just means that you're multiplying 1 by itself twice. And that gives you 1 times 1, which is 1. And then let's bring over the plus 4 that we had there. And I'm going to write really small here so I can fit everything. So 2 times 1 is 2, plus 4 is 6. So the point that I'm going to graph is negative 3, comma 6, which is what I got for y. We're going to repeat the process, now substituting negative 2 for x. So the inside, where you see x in the original equation, it becomes negative 2. And I'm going to do this quickly. I'm not going to really explain. It's the same process, just different numbers. So we are still following PEMDAS. 2 squared is 2 times 2, which is 4. And then we multiply. And then we add last. So we get 12. So our x coordinate there is negative 2, and the y was 12. So now we have 2 additional points that we can plot on our graph. So it's at negative 3, so let me go ahead and write that in our graph since it wasn't included there. So -3 goes straight up to 6, which is about there. And at -2, I need to go straight up to +12, which is about there. And we have enough information to sketch the right side of the graph. So I'm going to go ahead and attempt to do that. So here's the right side of our parabola. We need at least one point on the left side, and we're going to use the axis of symmetry to get the other points on the left side of the parabola. So that line splits the parabola in half, which means whatever was going on the right is going to be the same on the left. So on here, since we have a point to the right of the line, then we have a point to the left of the line. That axis of symmetry serves like a mirror. Think of it as a mirror. And on the other one is 2 units away, so count 2 squares to the left, and you have another point. So now we have points on the left, so we can sketch the left side of the parabola. So there it is. Let me outline it again. And there's your parabola opening up just like we said it was, and the vertex with the lowest point. I hope this video helped you.